Hello guys, this is Dave. Today we are going to solve part 3 of the most important MCQ series, okay? Alright, so let's start. Alright, so this is the first question. It is written, a uniform wooden stick of mass 1.6 kg and length L rests in an inclined manner on a smooth vertical wall of height h. Now it is given that h is less than L, okay? Such that a small portion of the stick extends beyond the wall. The reaction force of the wall on the stick is perpendicular to the stick. The stick makes an angle 30 degrees with the wall, and the bottom of the stick is on the rough floor. The reaction of the wall on the stick is equal to the magnitude of the reaction on the floor on the stick. The ratio H upon L and the friction force at the bottom we have to find. These are the four options given, okay? Alright, so this is the figure. This is the wall, this is the floor, okay? And the wall has a height h, and it is written in the question that rod is extending beyond the wall. This means the rod is like this, okay? And very important thing, rod is at rest. Okay, just read the question carefully. It is written rod is at rest. This means it is not in motion. Hence, the forces are balanced, okay? Whatever directions, the forces are balanced. Now, what happens is, this whole length is L, okay, and it is written that the normal of the wall on the rod is perpendicular to the rod. So this is the rod, this is the direction of rod, hence the perpendicular direction would be this. So this is N, and it is written that normal of the wall is equal to the normal of the floor. So normal of the floor would be like this. Alright, let us consider this is the weight of the rod, mg. Weight will act as center of gravity, hence rod from this side will be L by 2 and this side would be L by 2, okay? So now it is given that this angle is 30 degree. Okay, I am just extending this line, okay? So since this angle is contained in these two lines, so this is 30 degree, this is perpendicular, so this should be 60 degrees. Now we resolve the forces on the rod, okay? How do we do it? First we take the vertical forces. Verticals are N plus N cos 60. This equals to mg. Alright. This is the vertical equation. And since the rod is not moving, hence there is an opposing force over here. This would be friction force F, which we have to find out, okay? And there is another force. This would be the vertical component of N. This would be N sin 60, okay? So the friction force would be equal to N sin 60. First we solve the first equation. Cos 60 is half, so this means 3n by 2 would be equal to mg. N would be equal to 2 by 3 mg. Alright. And now we have to calculate F. F would be equal to N sin. What is sin? Sin is root 3 by 2, right? Sin 60. What is N? N is 2 by 3 times mg times root 3 by 2. Okay. This cancels out. What is m? M is 1.6. I am taking g as 10. So we have 16 root 3 over 3. Alright. This is the frictional force. 16 root 3 over 3 newtons. Okay. Now I want to find out the ratio of h by L. What I do is, I take this point. For example, this point, let us say this is P, this is A and this is B. I take PA to be X. Alright. This length is X. This would be L minus X, obvious. Now since this rod is also not rotating, okay. This rod is not rotating. Hence, torques are also equal. Forces are balanced, yes, but torque is also balanced. Now I am taking torque about point A. Since forces N and F are on the point A, these will not produce torque because they are on the point A. Hence R becomes 0. Alright. Since torque is R cross F. Okay. Only torque produced will be by N and by mg. Okay. N about point A is vertical and is 90 degree with the R, which is X. Okay. So this means N times X sin 90, okay. This would be equal to mg times this would be L by 2 as mg is on the center, so L by 2 from A, and this would be angle 30 because these are parallel lines and this is transversal, so this angle would be 30. So this would be mg L by 2 sine 30, which would be half. Okay, this is another equation. What is sine 90? Sine 90 is 1, so nx would be equal to mg L over 4. Okay, what was n? N was 2 by 3 mg x. This would be equal to mg L over 4. mg gets cancelled out. X, what is x? X is 3L by 8. Okay, so here x is 3L by 8. Now, what was cos 30? You see, originally this was the figure. This is angle 30, this is h, and this is x. Okay, till this point. So what is cos 30? Cos 30 is h by x. So cos 30 h over x. What is x? 3L by 8. So we take 3 by 8 over here. We have 3 by 8 times root 3 by 2, which would be h by L. Alright. So this is the answer. So h by L is 3 root 3 by 16. This is the answer. 3 root 3 by 16 and f equal to 16 root 3 by 3 is the answer. Okay. Okay, so here my answer is D. H by L is 3 root 3 by 16 and f is 16 root 3 by 3. Okay. Alright, so let's move on to the next question. It is written, a bullet is fired vertically upwards with velocity v from the surface of a spherical planet. Okay. When it reaches the maximum height, its acceleration due to the planet's gravity is 1/4 of its value at the surface of planet. Alright. If the escape velocity from the planet is v escape equal to v root n, then we have to find out the value of n by ignoring energy loss due to atmosphere. Okay. Alright, so this is the figure. This is a planet of mass big M, capital M, and this is object of small mass m. It is actually this is a bullet and it is thrown with a velocity and it's fired with a velocity v. Okay, so it is given that at maximum height the acceleration due to gravity, let us say g dash, at this maximum height is equal to 1/4 of the acceleration due to gravity of the planet when the bullet is at the surface. Okay, so as we all know, the acceleration due to gravity at the surface, since it is being balanced, if it was not, then it would have been gm by r square. Okay, this is the acceleration due to gravity at surface. Okay, and acceleration due to gravity at any height h would be equal to gm by r plus h square. Why? This is because the force would be equal to gmm by r square. Okay, force is gmm by r square, and r is the distance between the body and the center of this planet. This means if this body reaches a height h, this is h and this is r, so total becomes r plus h. Okay, so we will substitute small r, we will substitute h plus r in place of small r. Okay, so it is given that g dash equal to g over 4. Okay, this is given. This means gm by r plus h whole square, this is equal to gm by r square, right? Gm gets cancelled out, and g dash is this 1 by 4. Actually this is 1 by 4. Okay, so we take the root of this, square root of this, we get 2r equal to r plus h. H is h max, and h max equal to 2r minus r, which is r. H max is r. Alright, so now I want to find out the velocity at h max. What will it be? You see, we now use the energy equation. At this point of time, when object is at the surface, it has two energies, because initial velocity is v. This means it has one energy in the form of kinetic energy, other in the form of gravitational potential energy due to the planet, which would be gmm by r. Okay, then again this would be gmm by r. This would be the gravitational potential energy, and now it reaches a height h. Okay, what is the energy now? Since it is a maximum height, this means the final velocity should be 0. Okay, since it is its maximum, it cannot go beyond that. Okay, it has to come back. This means the final velocity at this point is 0. So no kinetic energy over here. Only thing left is potential energy. What is potential energy? Gm by h plus r. Okay, what is h? This h is equal to r. This means minus gmm by h plus r would be 2r. Okay. Now we take this expression over here. We have half mv square equal to, this would be gmm by 2r. Okay. 2 gets cancelled, mm gets cancelled. So v is root gm by r. Okay. This is the velocity. This is the velocity with which the bullet was fired initially. Okay. Now, what is the escape velocity? You see, escape velocity means when the planet escapes the forces of the, when the body escapes the forces of the planet. Okay. This means if we are trying to take the work done. Okay. Let me show you over here. You see, when a planet, when a body is thrown upwards and it has a velocity v, this is the planet. Okay. It has a radius r. Okay. Initially, what is its energy? Energy would be half mv square minus gmm by r. Okay. So you see, in escape velocity, what happens is this kinetic energy should be greater or equal to this gravitational potential energy. This means this. So v escape is the minimum escape velocity. Okay. Since v escape actually is greater than root 2 gm by r. Okay. Yeah, you see, the kinetic energy of the body has to escape the gravitational potential energy of the planet. Only then it can go beyond the gravitational field of the planet and go into outer space. And when such a velocity, is given, this is called escape velocity. Okay. Normally, this is the expression for escape velocity, but the minimum escape velocity would here be 2 gm by r. Okay. Now, what was v? V escape was given as v root n, right? So v escape is this, and what is v? V was root 2 gm by r, right? So root gm by r, this means v escape here is root 2 times v. Okay, so we can compare it, n comes out to be 2. Okay, n equal to 2 is the answer. All right, so moving on, we have another question. Two identical uniform discs roll without slipping on two different surfaces A, B and C, D. Okay. Starting at A and C with the linear speeds V1 and V2 respectively, and always remain in contact with the surfaces. If they reach B and D with the same linear speed, then we have to find out V2. Okay. Alright, so this is the problem. Okay. What are we given? H1, H2 and V1 and G. What do we have to find? V2. You see, one thing is that this disc actually comes down and reaches the point B with velocity V1, and this also reaches the point D with velocity V1. Okay. Since the surfaces are smooth, there is no friction over here since the discs are not slipping. So we can assume that energy is conserved. Okay. Energy is conserved. We are assuming energy is conserved because there is no non-conservative force like friction acting over here. All the forces are conservative. Okay, so this means the kinetic energy initial would be equal to the sum of kinetic energy and potential energy initial would be equal to the sum of kinetic energy and potential energy final for both the cases. Okay, you see, in the final case there is no height. Okay, hence the potential energy goes. Okay, it goes away. Final kinetic energy. Alright. You see, final kinetic energy of both the discs are same because the velocity is same. And it is given that the discs are same, so masses are same. Hence, half mv1 square. Here would be the final kinetic energy. Also, here also it would be the same. This means Ke initial for A plus Pe initial for A would be equal to Ke initial for C plus Pe initial for C. Alright. We can directly equate the two. Okay. So, what is the kinetic energy of A? You see, kinetic energy of A would not only be half mv1 square. And yeah, here also I forgot to mention that final kinetic energy would also consist of half I omega square. Okay. So also I is same, omega is same since radius are same because discs are identical. Okay. I would be same, omega would be same. This is the final kinetic energy of the disk, okay? And these are same, alright, for both the disk. Because after reaching point B, the velocity is v1. So omega would be equal to v1 by r. And here also omega would be equal to v1 by r, alright. So the kinetic energy would be the, sliding kinetic and rolling kinetic, alright. This kinetic energy would consist of rolling kinetic energy half I omega square plus sliding kinetic energy, which would be half mv square, alright. And the potential energy would be equal to mgh1. Here also the kinetic energy would consist of half mv2 square plus half I omega square plus mgh2, alright. Here you see omega has changed now. Initially the velocity was v2, finally velocity was v1. Hence initially omega 2 would be v2 by r, alright. Because omega equal to v equal to r cross omega, as we know. So omega would be v2 by r, but not here. In the final point D, omega would be equal to v1 by r. So it would make the rotational kinetic energy also same, alright. Initially it is not. We have this equation. So you see omega is v by r, alright. And this I is half mr square for disk. So we have 1 by 4 m r square times omega. What is omega? V square. This would be v1 by r square. R gets cancelled, plus half m v1 square, okay, plus mg h1. This would be equal to half m v2 square plus 1 by 4 m r square times v2 square by r square. This would not be v1, alright, because here velocity is v2 initially. Finally the velocity is v1 plus mg h2. So this goes out 1 by 2 plus 1 by 4. This will give us 3 by 4, right? And here also this will give us 3 by 4, okay. And h1 was 30, h2 is 27. h1 is 30, h2 is 27. So we have here 3 by 4 m v1 square plus mg h1. This would be equal to 3 by 4 m v2 square plus mg h2, right? Gets cancelled out because the disks are same. What is v1? v1 was 3 meters per second, right? So 3 into 9, 27 by 4 plus g was 10, right? Because so 300, this would be equal to 3 by 4 v2 square plus 270. This goes here. So we have 30 plus 27 by 4. This would be equal to 3 by 4 v2 square. 4 3 are 12, 120, 147 by 4 equal to 3 over 4 v2 square, okay. 3 4s are 12, right? 3 9 are 27, 4 gets cancelled, v2 is 7. So answer is 7 meters per second square, okay. You see, as I already told you, I am telling you again, initially the velocity was given v2, we had to find this, but in the end it was given that both the disks arrive at this end point with velocity v1. So omega will change here. Omega will now be v1 by r, alright, as we have the final kinetic energy. But here omega would be equal to v2 by r, alright. v2 equal to 7 is the answer, okay. Alright, so let's move on. A cannon fires successively 2 shells with a velocity v0, 250 meters per second. Okay, the velocity is same, this means, okay. The first at an angle theta 1 equal to 60 and second at an angle theta 2 equal to 45 to the horizontal. The azimuth being the same, neglecting the air drag. You see, he has neglected air drag, okay. Find the time interval between the firings leading to the collision of shells. So we have to find the time, during which the shells collide. Alright, so this is the figure. You see, 2 projectiles are thrown with the same speed, okay. One is thrown at an angle theta 1, the other is at an angle theta 2, and they collide. You see, one thing I have to tell you guys, that when they collided, then the coordinates of this point would have been same for both the particles, okay. because they are at the same point during the collision. You know, this is the y coordinate and this is the x coordinate. Okay, so we will make use of this. Okay, what is the x coordinate of a projectile? It is v naught cos theta times t. Okay, suppose this projectile takes a time t. This is the first projectile, and this projectile is thrown after time delta t. All right, so for the first projectile, x equal to v naught cos t, cos theta t. Okay, since it has taken time t from going from 0 to p. The next projectile would have an x equal to v naught cos theta t plus delta t. Why? Why? Because it was thrown after time delta t. Okay, or we can say it took delta t longer. Okay, we can say it like this. All right. So these are the two x coordinates. Okay, I have to find this delta t. All right. You see, we have to find the time interval between the firings which leads to the collision of shell. All right. This means the second shell must have been fired after some other time. Okay, so this time is delta t. Since the x coordinates are same, this means v naught cos theta t, this would be equal to v naught cos theta t plus delta t. v naught gets cancelled out. This is theta 1 and this is theta 2. All right, so what is t over here? You see, t would be equal to delta t times cos theta 2 divided by cos of theta 1 minus cos of theta 2. Alright, this is the t in terms of delta t, because I have to find delta t, so I will eliminate t. Okay, so what is the y coordinate? You see, y coordinate for the first particle, because y is also the same. Okay, since in collision they are at the same place. This would be v naught sine theta 1 t minus half gt square. For the second particle, it took delta t longer. This means for second particle, y would have been v naught sine theta 2 t plus delta t minus half g t plus delta t square. Okay, this is the y for the second particle. Since both the y are same, this means we have to equate. So we have v naught sine theta t minus half g t square equal to v naught sine theta 2 t plus delta t minus half g into t plus delta t whole square. Okay, this is it. You see, since this projectile, first projectile, let us say, was fired at t equal to 0. Alright, and it took time t. Next projectile was fired at t equal to delta t, and then it will take t plus delta t time. Okay, so these are the y coordinates we have equated. Now we have to just solve this. T equal to delta t cos theta 2 upon cos theta 1 minus cos theta 2. Let me write it here. T equal to delta t cos theta 2 divided by cos theta 1 minus cos of theta 2. Okay, so we have v naught sine theta t minus half gt square. This would be equal to v naught sine theta 2 t plus delta t minus half gt plus delta t whole square. Okay, let's expand this. We have v naught sine theta 2 t plus v naught sine theta 2 delta t minus half gt square minus half g delta t square minus gt delta t. Alright, so this cancels out, and I'm transferring this term on the left hand side. So we have v naught sine theta 1 minus sine theta 2 times t, right? This also will be transferred, so we have minus v naught sine theta 2 delta t. This is equal to, this is separate. Okay, this is equal to minus half g delta t square minus gt delta t. Okay, alright, so now let us substitute t with this expression. Okay, so what we have here, after substituting, we have let me remember this, v naught sine theta 1 theta 2 t minus v naught sine theta 2 delta t minus V naught sine theta 2 delta t. This was minus half G delta t square minus G t delta t. Okay, delta t we know, t we know. Okay, so I am substituting t. We have V naught sine theta 1 minus sine theta 2 into what? Into we have delta t cos theta 2 divided by cos of theta 1 minus cos of theta 2. I am solving LHS first. Okay, minus V naught sine theta 2 delta t. Okay, so we have V naught sine theta 1 cos theta 2 minus sine theta 2 cos theta 2, taking V naught delta t common, and minus sine theta 2 cos theta 1 plus sine theta 2 cos theta 2. Okay, this gets cancelled out. Division cos of theta 1 minus cos of theta. So LHS is V naught delta t times sine of sine A cos B minus cos A sine B. This means sine A minus B. Okay, divided by cos of theta 1 minus cos of theta 2. This is equal to minus half G delta t square minus G t delta t. Okay, delta t can be divided. Okay, so we have V naught sine of theta 1 minus theta 2 upon cos theta 1 minus cos theta t equal to minus half G delta t minus gt. Okay, so we have V naught sine of theta 1 minus theta 2 divided by cos theta 1 minus cos theta 2. This would be equal to minus half G delta t minus gt. Again we apply the expression for t, so we have minus half G delta t minus, okay, G delta t cos theta 2 divided by cos of theta 1 minus cos of theta 2. This is equal to this. Okay, so taking G delta t common and minus sign also common, we get cos theta 1 minus cos theta 2. Since we have taken minus, this would be plus 2 cos theta 2, right, divided by 2. So this would be, and divided by cos of theta 1 minus cos of theta 2. This expression would be cos of theta 1 plus cos of theta 2 divided by cos of theta 1 minus cos of theta 2. Okay, and this would be, this is the expression, I think. This would be minus G delta t by 2. Okay, and here we have V naught sine of theta 1 minus theta 2 divided by cos of theta 1 minus cos of theta 2. So this gets cancelled out. So time would be, delta t is minus 2 V naught by G sine of theta 1 minus theta 2 divided by cos of theta 1 plus cos of theta 2. Okay, and minus, time cannot be negative, so sine of A cos of B minus cos A sine B, so that will be reversed. Hence this would be, delta t final expression would be 2 V naught by G sine of theta 2 minus theta 1. Okay, because this would be sine theta 1 cos theta 2 minus cos theta 2 sine theta 1, and when minus is added, this would be sine theta 2 cos theta 1 minus cos theta 2 sine theta 1, right? So this would be like this, and this would be cos of theta 1 plus cos of theta 2. This is the final answer. Okay, the time lag leading to the collision of shells, this is the answer. Okay, 2 V naught by G sine of theta 1 minus theta 2 minus theta 1 divided by cos of theta 1 plus cos of theta 2. Alright guys, I'm stopping here. I will continue with the MCQ series, and then we'll move on to simple harmonic motion and then fluid mechanics. Okay, please like, rate, review, subscribe and recommend. Okay, thank you very much.